require local contractors to post or be able to issue an insurance for the workers in the amount of $1 million per worker. And no Philippine insurance company is capable and willing to provide that. So what normally happens is that it's being waived because the local insurance companies are only willing to pay maximum of maybe $2,000. So instead of complying with regulation, sometimes it's cheaper just to violate, pay the fines, or not pay the fines like what Jojo mentioned yesterday. The penalty now is what?
$2,000 per day.
$2,000 per day to violate. But if there's a fatality, it's only 1,000 per person. So even if you have penalties provided by law, it's still cheaper not to follow it. That's the problem. So we have always discussed personal safety. Why? Because it said that 90% of accidents is caused by unsafe acts and 10% unsafe conditions. Unsafe conditions vary, and very few can say that they are capable of preventing all these unsafe conditions, because most of these unsafe conditions are inherent in the process, or it's already in the environment. You can't do anything about it. So what you can only do is provide probably the workers or those within the vicinity with PPEs to protect them from the hazards of the environment or the workplace. This is the reason why there are a lot of accidents involving the process. Not what the workers did, but what hazards are inherent in the process. And this was recognized by the OSHA as early as 1992, when they developed 29 CFR Part 1910, which is the process safety management of highly hazardous chemicals. The raw materials, the process itself is hazardous, which can result in releases of these hazardous chemicals to the environment and affecting not just the workers, but even the entire community. Perfect example is the Bhopal incident, when there was a significant release of isocyanate gas, which killed, the maximum that's being reported is around 15,000 people from the community. So the purpose of this process safety management standard by the OSHA is to help employees prevent and mitigate catastrophic releases of highly hazardous chemicals that may have a great impact on workers, the public, and the environment. What the OSHA provides for is protection of the workers from the release. But it's going to be difficult for anybody to prevent this release from happening, because this is dependent not just on the process, but the mechanical design of the equipment that will handle the process. Very few safety professionals are competent to evaluate process safety. That's why majority of the procedures that we have is towards protection of workers that may be exposed because of releases of hazardous chemicals. So this regulation, although it has a long name, it's simply referred to as the PSM, or Process Safety Management Rule. And this rule contains 14 elements. So it's the hope of OSHA that by following these 14 elements, or having a documented system to comply with the requirements of 14 elements, then you can operate your facility throughout its entire life cycle. What's the normal life cycle of a plant? Normally plants are designed to operate for 20 years, or around 200,000 hours of operation, 20 years. So the 14 elements gives a comprehensive management program for identification, assessment, and control of chemical releases. These are all after the fact. You cannot evaluate the process itself or even the design of the facility that's handling the process, because this is beyond the expertise of safety professionals. This is in the territory of process engineers, mechanical designers, and there are very few process engineers and mechanical designers who are also safety engineers, just like what you mentioned earlier this morning. So we are experts in industrial hygiene. We tell them, you use this, you monitor this. If the monitor indicates this level of exposure, just leave the area. But we are distant from the workers who are actually involved in that particular activity. It's easy for us to say, do this, do this, do that. When in fact, we ourselves have that experience doing it.
Monica has experience now.
Now she has experienced it. So the PSM approach process risk by having safety requirements at the design and plan stage of a process. Who will control the safety of the process when the process is still being designed? Is there any specific standard or regulation to guide us on how to go about this requirement? It's up to the process engineer. And it's normal that if you design a process, you feel good about your process, you always say, that's the best, that's safe. And you wouldn't want somebody else meddling with your design. That's why in the process of evaluating process hazards or in the procedure, normally you do not include the process designer. Because whatever you say about this process, any comments you make, his tendency is to be defensive. He will not accept. This is my process. I have patents for this process. Who are you to tell me that? What's your qualification? You're just a safety professional. You know many things about personal safety, but the process is mine. So they own the process, that's true, but I doubt if they have sufficient knowledge on the impacts of the process if anything goes wrong. And then, once you have identified the risks of the process, then you maintain these requirements and controls and prevent accidents from happening during the entire life of the process. Unfortunately, I have seen a lot of plants, especially in the Philippines. As I mentioned earlier, these are designed for a life of 20 years, but a few months after it's put into service, for a few years, something goes wrong. That's the reality. Everything works very well on paper, but once it's implemented, then that's the time you see all the problems coming out. So the 14 elements in the PSM rule starts with process safety information, process hazards analysis, operating procedures, employee participation, training, contractor safety, pre-startup safety review, mechanical integrity, work permit, management of change, incident investigation, emergency planning and response, compliance audit, and trade secrets. It's important because not all are willing to divulge the details of the process. So let me discuss all these elements one by one. Process safety information. So you develop and maintain a written safety information which identifies what are the chemicals that are being used, either produced or even the raw materials, and the process hazards. This info you can easily get, especially for the chemical hazards, from NIOSH or list of other lists of chemicals which indicates all the hazards associated with it. the equipment that's used in the process, and the technology that is used in the process. So for chemicals, examples of information that's needed, is all IH professionals are very familiar with this. Toxicity information, exposure limits, physical data, reactivity data, corrosivity data, thermal and chemical stability data, compatibility data. For the process technology, you need to have information on the process flow. So this is well described in a process flow diagram. The chemistry of the process, the maximum intended inventory that the facility is able to handle, the safe upper and lower limits of the different operating parameters like temperatures, pressures, flow, composition, and the interaction of all these parameters. And then what will be the consequences if there are any deviations outside the identified operating limits. So in the process equipment, info on the material of construction, because there are a lot of accidents which happen because of wrong choice of material. Sometimes designers, especially if they're process designers, or even the mechanical designers, the mechanical engineers who designs the equipment to be used for the process, are not well versed with the properties of the material. So in most cases, they need to consult metallurgists so that they can appropriately choose the right material for that specific application. Piping, instrumentation diagrams, electrical classifications, and so on. And important is safety systems. What interlocks are needed, if you need detection systems or suppression systems in case of deviations from the operating parameters. That first element is very straightforward. So it's easy to get those information. Even if you're not a safety professional, you're a designer, you can easily get those. But what's the most important element of the process safety management rule is this second element, the process hazards analysis. And this is where the competency of those performing this process fails. They just do it for the sake of doing it. Because it's a regulatory requirement in most processes, you need to submit as proof of the safety of the process a process hazards assessment. Unfortunately, those asking for those requirements also do not possess the competence to evaluate as long as you're able to submit, and then the data that you submit with the analysis is acceptable based on regulation, then it's approved. It's only later on when the plant is put in operation that you see all the problems coming out. So PHA, or process hazards analysis, this is the most important element of the PSL program. So this is an organized, thorough, and systematic approach to identify, evaluate, and control process hazards. How is this done? You divide the process into different, they call it nodes. You identify what happens within that node, check all process parameters, and then you determine if there are any deviations that will occur during the process, what will be the consequence of that deviation. And then that's the time you will develop safeguards or controls so as to prevent that deviation from happening, or if it do happen, what will be the safeguards that has to be in place. And in most cases, if the deviation or the consequence of that deviation from the process parameters is significant, there might be a need to have redundant controls. So that if in case your first level of control fails, then you have a second control which will be able to address the problem. So the objective of process hazards analysis is to determine the risks and where control measures may be required so that you'll be able to manage those risks. Another problem here is managing the risk. Because sometimes we treat risks as hazards. Actual risk management requires you to identify the probabilities that that deviation will occur, and if it occurs, what will be the severity or the consequence. So it's not always that whenever you identify a hazard or a risk, you need to institute controls or safeguards. Because if the identified risk is very remote from happening, then why spend? Otherwise, your process design will become too expensive. The problem here is how will you identify or evaluate, quantify the risk. Because risks can either be tolerated or it can be addressed. If you think that the risk level is acceptable, then you're willing to take the risk. So that's one way of selling to management why you need this safeguard, why you need this control. Because this is the risk. Risk is a quantitative value. It's not something that you pick up from the ceiling and then tell them this is the risk and then this is what we need. You must be able to quantify. So that is a very good tool in order to sell to management that if we do not do this, this is the consequence. This is the cost, and the probability that that will happen is this much. And that is based on industry standard. Unfortunately, industry standards are not that accurate, especially if you're talking about special processes wherein designers and even operators are treating it as their trade secret. Even if there's something wrong, they will not admit it. They'll say this is still the best process there is. So tasks and the third element is operating procedures. So these are tasks and procedures related to the process that must be appropriate, clear, consistent, and well communicated to the employees. Everything that's happening outside the process equipment, it can be covered by procedures. But the problem here is you have no idea of what's happening within the system unless you have sufficient number of monitoring equipment controls, and these controls will sometimes fail. Just like what happened in the Deepwater Horizon. So they have monitors there, but there was a misinterpretation of the data. That's why the well burst. So this includes the operating limits of the process, safety systems, and safety and health precautions. Safety and health precautions, this is towards addressing releases of the hazardous chemical and its effect on the people around the process. While operating limits of the process and safety systems, well, you have monitoring devices, you have gauges, but again, these gauges can give you sometimes false readings. Another aspect of operating procedures is the startup. Startup is very critical. What happened with the Texas refinery explosion? It was during their startup. So the tower was filled with fluid which overflowed because proper procedures were not followed, aside from having defective or old equipment, outdated equipment. So temporary operations, emergency shutdown, including the conditions under which emergency shutdown is required, and assignment of shutdown responsibility to qualified operators to ensure that emergency shutdown is executed in a safe and timely manner. So we often see this requirement, assignment of qualified operators. But because of schedule problems, emergencies that the workers have to attend to, just like what happened with the Texas refinery explosion, the supervisor in charge got a call because his son, who was in school, had a minor accident. So he had to leave, and he left the startup of the refinery to somebody else. So for him, that person might be qualified, but because of what happened, maybe he's not. So emergency operations, normal shutdown, startup following a turnaround or after an emergency shutdown. What are the operating limits? What will be the consequences of deviation? And steps required to correct or avoid deviation. You can have all these procedures. If you perform an audit, you ask for all these procedures, they will present it to you. But unfortunately, in practice, it's just a document which is most often not followed. Procedures are just for the consumption of the auditors. If you ask the operators, the technicians, have you read these procedures? Are you familiar on what to do if this happens? Unfortunately, they won't be able to give you the correct answer. So the documentation is just for the auditors. And what auditors do, because especially for special processes, they just look at the documentation and they check for the presence of those procedures, of those documents. Okay? Comply, comply, comply.
So question,
Yes.
if that's the case, how do you evaluate, and I'm saying, I've seen some of it, how do you then evaluate how effective your process truly is? Because if your audit comes up good, but it's only on paper, not really being delivered in the facility, how do you then evaluate, how do you truly know how good you are?
Again, it all depends on the safety culture of the company, of the management of the company. Because just like what happened with the Texas refinery explosion, it was part of the CSB report, Chemical Safety Board, that they do not have sufficient auditors that are qualified to evaluate special processes. Yes.
Yeah, I was going to say, don't you also have you have the opportunity to evaluate the failure cycles and estimates of the individual parts as you assemble that. And you can simply either add those up or average it and have some sort of failure expectation, failure cycle. You know, so I think
Because most of these audits are done based on existing regulations. And these regulations are late when it comes to addressing new technologies, new processes. So what may be applicable for old processes may not be applicable for a newly developed process, which is aimed at optimizing process efficiency in order to increase profitability. So that's always the case. It's the regulation that follows the technology, especially if there are problems encountered in the implementation. Yes.
Typically, this is done after an incident.
Yes.
You've got to be really sharp because you hit one obstacle after another. This isn't closed, this is, the gauge is wrong, the miscommunication in the field, you got to have somebody on the control board, you got to be checking this, your sample points, high and low point drains and everything else. This is a tedious process.
Yes. And there's a big tendency for operators, workers, supervisors, and even managers to make a shortcut. All the procedures of this refinery were reviewed, even the company policy, the mother company policy and they're perfect. It's the implementation which created the problem.
Well, but during shutdowns, you can refine this process and making sure everything is correct. Is that not right?
Yes, that's supposed to be the purpose of the shutdown, the turnaround. Yes.
Right.
But unfortunately, in most cases, they are being pressured by schedules. If they see a problem and they're scheduled to operate in 2 days, okay, let's do that in the next scheduled shutdown. They're being pressured to follow the schedule.
I think you said something, Kennedy, kind of right on the bullseye. If you have an organization where deviations to process are accepted, I think there's a lot greater risk of the best process that passes every audit and every ISO certification can fail you if there's not a philosophy in the company on what you do whenever those risks present themselves. So if it's not acceptable and the company's made that visible through their actions, the leadership of the company up to the senior management has made it visible that
But if you
those
do the
deviations,
procedures, they comply with everything.
procedures are worthless if they're not followed. That's why I think we saw something like the Deepwater Horizon that just received the biggest recognition for safety and health within their organization a few days prior to their blowing up. So
Certainly is no lost time injuries or anything like that.
Yeah. Even the Texas refinery, same thing.
so it's how they put their expectations.
But going back to the 7 years, that's not that they do not have injuries or fatalities, it's subcontractors that have their knee on the major companies, especially the network, this safety management, and subcontractors that do get injured and then they get let go when they get their subcontractors.
But if you look at the final report, there were a lot of accidents even prior to the main event, which were all ignored.
I were reported to the head office, and head office
Because
relayed
they
the
wanted
information they had.
to meet the schedule. This has to be done. We need to operate by this date, otherwise we will incur so much loss. That's always the direction given by management.
But it's also, I think, it's when we focus on those catastrophic events, there are many good companies that actually have a maintenance schedule. They've estimated the failure rate of the component parts and they replace those, and so they continue to stay in operation and make money and don't have events. So we're focusing on the reasons why that can happen. But I think that we have the tools and abilities to make fairly good estimates on maintenance cycles based on failure rates of component parts, and hence understand the failure rate of the entire system or its vulnerability, right? So I think it's not all doom and gloom. It's
Yes. That's why I said it depends on the safety culture of the company. If their main concern is profit, then they would say, okay, even if based on test and past performance, we need to replace this component, but anyway, we have a scheduled shutdown 6 months from now. Let's postpone it this time, operate because we need to produce, so let's reschedule it for 6 months anyway. Nothing will happen in the next 6 months.
Accident that happens anytime. Yeah. Go ahead and start it up.
That's what happened, that we just take care of everything 6 months later, and then right after starting up the operation, then you have this problem. It's the mentality that will not happen immediately. It will take, we still have time. So training. All employees, including maintenance and contractor employees involved in highly hazardous chemical processes, must be trained on the safety and health hazards arising from the chemicals, routine process operations, as well as non-routine tasks. Again, it's difficult for the all employees to appreciate, especially if you talk about the process and then they're not involved in that process. And those involved in the process will say, oh, I know that very well like the back of my hands. Complacency. And the employer must also identify the initial and refresher training requirements for the employees. This they can easily apply with all the training requirements, attendance for the training, but the quality of the training and how to spot problem areas, that's not part of the training. The training is more on how to respond if there's a chemical release, usually hazardous chemicals. Fire is, will also be present if there's a release. So most of the training is centered on those emergencies or those reactions. But spotting or what are the consequences if there's a deviation in the process, that's not up for the technicians to bother with, because they say, that's the problem of the process engineer. I don't have to be trained. But who's the one going around the facility inspecting for all the things, for all the deviations that's happening? These are the technicians. Then they'll have to report it to the process engineer. Usually they'll say, why don't you check? Maybe there's a problem with the gauge. Yes.
Question on those process engineers and how level of training, would you train them in the HAZCO operator, like a 40-hour, or would you have incident commanders on hand to oversee that? What level would you have them?
Normally, process engineers, they're not required to undergo the HAZCO training. So the training we give to process engineers is how to perform AHA, process hazards analysis.
Okay. How about the
Because
technician?
the technicians also for the process hazards analysis. In fact, in the PHA procedure, so you need to assemble a team and you must exclude the process designer. Because otherwise you'll be defensive. So you get other process engineers familiar with the process, normally from the same organization. If you're going to make some revisions in the process of the mechanical design. But the problem is during the initial design of the process. So there will be a group of process engineers working on it. Then you need to get somebody else from the outside to have a better perspective of the process which the other group has designed. And if the reputation of the process designer is very intimidating, even if you get somebody else from the outside, they would always say, oh, that was designed by him. That must be good. Because he's well known in the industry. That's why of all the process hazards analysis procedures, the best one to use is the HAZOP, the Hazard and Operability Study. Because that way you do not rely on the expertise of those involved in the process assessment, because it gives you a guide on how to go about asking and identifying all possible deviations in the different process parameters. So hazard and operability study, so that's the best one. So in the Philippines, MIRDC, the Organization of International Office for the Philippines, has facilitated a lot of HAZOP studies for different companies, oil and gas, power plant, treatment plants, mining companies, because now the Philippine government is requiring all of these companies to have a HAZOP study of all their processes. So, contractors providing incidental, non-safety related services such as janitorial, canteen, laundry, and delivery services are not subjected to these regulations. Unfortunately, you mentioned swapper. If there's a chemical release, in most cases, because the organic employees of the company would want to do the cleanup, that's a mess. Okay, you call the janitor, tell them to clean it. Anyway, that's only a small amount of chemical, so call the janitor. So here I see some problem because that's spill, it has to be cleaned, it's the janitor's responsibility. Unless there's a specific company policy that will not allow them to ask the janitor. But if you're the manager, you want to hide the speed, you just call the janitor. You don't want to get your emergency response team to do the cleanup. Okay, janitor, that's your job. I'll pay for your snack later on. Pre-startup review. Majority of the problems occur after shutdown and during startup. So the objective of the pre-startup safety review is to ensure that safety requirements have been fulfilled prior to the introduction of highly hazardous chemicals to a process. Again, because of problems in meeting the schedule, sometimes they bypass. We have done this for the past several years. We have not encountered any problems. The reason why those procedures are there is because it's important. So it's not up for the supervisor to decide on whether to bypass a specific step. But because his ass is on the line, if he's not able to meet the startup schedule, then he's willing to take the risk and bypass some of the steps. Mechanical integrity. So equipment, including instruments used in the process for the storage and handling of highly hazardous chemicals needs to be designed, constructed, installed, and maintained to minimize the risk of hazardous chemical releases. The first line of defense against any uncontrolled catastrophic releases of chemicals is the equipment in contact with these highly hazardous chemicals. Again, another problem here is the material used. We have had a lot of problems in the Philippines, especially with materials coming from China. They will have all the documentations, all the certificates saying that this is the type of the material, these are the chemical and mechanical properties, but once it's put into service, the material fails. Perfect example is the nickel refinery in the Philippines, wherein the specified piping material is 316L. So it was ordered by, it was a Japanese contractor who constructed the plant. So they ordered the material from China. It's complete with all documentation, bill certificates and everything. But 3 months after it's put in service, the entire pipeline disappeared. It's not 316L, it's only 308. But it had all the markings in it, all the documentation.
It's a knockoff.
So that's why there's a joke in the Philippines that God created the world and the rest is made in China. So during maintenance works, so if there's a failed equipment and then there's a problem sourcing for the replacement material, again because of the schedule requirements, they just look at some publications and then maybe brochures of material suppliers that this is equivalent to this type of material. They buy it, use it, and then just discover that it will not perform up to standard. So now everything can be, we call it in the Philippines, can be faked. Especially materials. That's why most of the, especially for maintenance works, you do in situ chemical analysis, you do PMI, positive material identification, to be sure that the material supplied and you used is actually what is required. So even if you have the appropriate material or the right material, sometimes even the welding consumable suppliers will supply a different material. So after performing the fabrication, you need to check really if it has the appropriate chemical requirement, and also there are tests that can be done that will give you an indication of the mechanical property of the material, not just the chemical. So there are a lot of tests being done now. That's why when they prepared the nickel refinery, that's where the cyanide is flowing, that's the cyanide pipeline. So the entire length, every length of pipe, every weld joint was tested for it to have the correct mechanical and chemical property. You can no longer rely on documentations, even the markings of the material. That's the problem. Not work permit. All safety professionals are very familiar with that. That's straightforward. So we don't have to discuss that. Then management of change is again another issue. So they will have a very nice management of change program, but again, it's the implementation. All modifications of equipment, procedures, raw materials, and processing conditions other than replacement in kind are to be identified and reviewed prior to implementing the change. This was another problem with the Texas refinery, which resulted in the undercapacity of the blowdown drum. Replacement in kind is defined as a replacement which satisfies the original design specification. So if you change it to something that your supplier says that's the equivalent, then that's when you have problems. Incident investigation, again, is within the forte of safety professionals. So all incidents which resulted in or could reasonably have resulted in the catastrophic release of hazardous materials should be investigated. So this one, in safety we call that near miss. Unfortunately, not all near misses are being reported. The aim of this element is to prevent the recurrence of similar or related incidents with the same root causes. If you read the CSP report, there has been reports as far back as 10 years from the date of the explosion. Nothing has been done to correct that problem. Especially if the near miss happened and then after 2, 3, 4 years, probably that's just an isolated incident. There's no need for us to spend so much just to correct that near miss. Emergency planning and response. So this is where your CASWAPER team, your emergency response team. So with this element, safety professionals are on top of this. But what concerns us most is the upset or deviation in the process, not the response after the release. Compliance audits on effectiveness of the PSM program shall be evaluated and corrective and preventive actions taken to remove any deficiencies. But again, this all depends on the qualification and the competency of the audit team. If they say, oh, this is a big oil company, they have magnificent procedures, just like you mentioned, the name itself is intimidating. So you pass the audit with flying colors. The audit team should be independent, although it must include one member knowledgeable of the process, and this person would be involved in the operation of the process. Unfortunately, in the Philippines, this never happens because most of the government auditors, the regulatory inspectors have no industry experience. They join the government straight from school, and they remain table engineers. Because the table engineers, they gain their experience on their desks, and they retire on their desks also. No idea. So they will require something that just pop up into their minds. For them, it's best to, especially for process equipment, to have it checked regularly. To shut it down, check it, and then operate it. What they do not know is that this shutdown and startups creates more stress to the equipment. It shortens the life of the equipment. Even if we adopt the US standards or regulations, like for example, for pressure vessels, here API recommends that it be tested from initial use after 10 years. For boilers, same thing. In the Philippines, they say every year you need to shut it down, you have to hydro test it. Industry is complaining it stresses the equipment more than the good that we can get from testing it. Shutdown, startup, hydro testing. The American Society of Mechanical Engineers require that the test pressure be 1.3 times the design pressure. But in the Philippines, no, we use higher test pressures. The higher, the better. That's the result of being table experts. So because of industry is questioning the effectiveness of that regulation, then what they did, they proposed an alternative test. So instead of doing hydro testing, they say to do ultrasonic testing, which we again question, because you cannot use that type of test to replace. What we're asking is for them just to extend the frequency of the test. So instead of making it every year, follow the ASME or the API standards. But sometimes if you argue, they will say, then why don't you practice in the US? Because you're always naming US standards. So you have no choice just to comply. So that results to premature failure of most of the equipment. So right now, new equipment will fail on the average 3 years. 3 years.
Have you guys looked at what types of non-destructive testing help give you a picture of future risk of failures? So what I want to talk about is we do a number of different non-destructive tests on our equipment, and have developed enough data to figure out if those non-destructive tests, the results that they present can be a predictor of future failures. So nothing substitutes for those overpressure tests like you just mentioned, but there are some other technologies by which you don't have to take that equipment past normal design in order to get a picture of where you're at right now, what your risk of failure is. I'm just interested if you guys look at different non-destructive.
It's being done by the industry. It's industry-led in the Philippines. There's no regulation, but it's being done by the industry. That's why industry complies with the requirements of the government, but they do something else which complies with international standards. So industry, they do remaining life assessment for their equipment and follow strictly the requirements of, especially for the petroleum industries, the API standard. So it's being done. We have the technology, but our main problem really are the regulators.
Yeah,
Mostly headed by politicians.
It's a tough conversation to convince regulators who have very little practical knowledge about your field that a non-destructive test can yield the same type of results that more extensive testing could. So it's a back and
Yes,
forth.
that's the problem.
Yeah.
In fact, if I may mention, so one of our friends, who's the head of the Occupational Safety and Health Center in the Philippines, and he's attending the WHO conferences and presenting some papers, also was transferred to a different department just 2 weeks ago. He was supposed to attend this conference also for political reasons, not for competence. That's unfortunate.
Should come to Latin.
Trade secret.
No politics.
Now I'll share with you some accidents which happened in the Philippines. Although we tried to follow the PSN rules, so we followed the recommendation of the equipment manufacturer and supplier on the maintenance program. Just like this flow of gas compressor for a polyethylene plant. So this is the piston. The piston rod is around 4 inches in diameter. So maintenance was done on the compressor. It was dismantled. When they removed the nut holding the piston in place, so they discovered some stripping of the thread under the nut. So what they did, so it's practiced by workshops just to remove the strip portion and still maintain the. But unfortunately, what happened when they used a triangular file, the file also damaged the value of the thread, creating a small nick which acts as a stress laser. So when the compressor was put in service, in just a few minutes, it exploded. So there was a vapor cloud, and the explosion was heard probably 10 miles away. The other end of the piston rod. So it was removed. So this is how it happened. So the crack initiation point started here. We applied the correct torque in tightening the nut, but because of this stress laser here, so just a few minutes after it was operated, this is the hydrogen plant also in the Philippines. So hydrogen was being loaded in this hydrogen trailer. Then the detail assembly connecting the trailer to the loading platform failed. So they were able to shut down the source of the hydrogen, but they can no longer shut down the hydrogen that's already in the trailer. So they just waited for the hydrogen to all burn up. And then when the fire department came, the recommendation is add more fire extinguishers. So that's how we do it in the Philippines. We know the standard, we follow the standard, but we also do other things just to satisfy the government regulation. This is what happens. So there are no closing valves there. So this is another accident which happened in the gas plant. So this multiple stage air compressor. So it sucks air from the atmosphere, and then there's a gas separation plant. So they primarily produce hydrogen also. Again, after maintenance, following the maintenance schedule, prescribed by the equipment manufacturer. So this impeller type. So the impeller on the second stage, the holding bolt of the impeller in the second stage failed. Then this got caught while the impeller is still rotating. So that's the reason why the base got stripped. So the problem here is that the bolt was not properly tightened. Simple tightening of the bolt led to the failure of the entire compressor, and the plant was shut down for several weeks just to order the replacement parts. So you have good intentions, you follow procedures, but because of small things, these things happen. For the Texas refinery explosion, what was the CSP finding? Organizational and safety deficiencies at all organizational levels contributed to the refinery explosion, such as cost cuts and spending cuts in the city area. Although a large part of the refinery infrastructure and process equipment were in poor condition. The company had cut the budget for training and reduced staff. After the explosion, OSHA found 301 violations of requirements and imposed a fine of $21 million. That's just the fine for OSHA. But the lawsuit that followed, they paid millions of dollars to the victims. The CSP found that only a limited number of OSHA inspectors received the specialized training and experience necessary for complex investigations in refineries. So the Philippines is not alone, although we're 100%. While here, a limited number. So if you summarize the investigation result, the accident happened because of unsafe equipment design. There were modifications that were not thoroughly evaluated. Startup procedure was not followed, properly followed, lack of training, maintenance procedure, and most important, the main cause is actually cost cutting. So I managed to research this also. 10 years later, there is little evidence that the 15 lives that were lost in the Texas refinery explosion on that March day bought much of anything. The death toll at U.S. refineries has barely slowed, based on evidence assembled by Texas People Houston Chronicle investigation. So, 64 energy company employees and contractors were killed in the decade before the 2005 Texas heat blast. And at least 58 have died in the 10 years since. The investigation report was very thorough. They made a lot of recommendations. In fact, API has revised most of their procedures as a result of the accident. But even with the revisions in the OSHA standard, the API standards applicable to refineries, the number of deaths remained almost the same. 64 before the accident and 50 after. So there was very good investigation, accident investigation conducted, good recommendations, but why is this still happening? That means it's also not being implemented. It is according to the data compiled from newspaper archives, occupation seat and administration records, and lawsuits and union reports. Deepwater Horizon rig. So this is semi-submersible. And if I may read part of the report, the National Commission on the BP Deepwater Horizon oil spill and offshore drilling released a final report on 5 January 2011. The panel found that BP is the operator, Halliburton is the contractor, and Transocean is the owner of the well had attempted to work more cheaply and thus helped to trigger the explosion in its utility case. The report stated that whether purposeful or not, many of the decisions that BP, Halliburton, and Transocean made that increased the risk of the Macondo blow clearly saved those companies significant time and money. So this is the worst oil spill in U.S. history. Again, what's the reason behind? The root cause is cost savings. So now let me ask you these questions. Will process safety regulations ensure safe operations of plants and processes? Can regulations cope with advancements in process design and its corresponding mechanical design? Can regulatory inspectors timely acquire the competence to cope with these advancements? And will companies always prioritize safety over profitability? Let's think about it.